do the chat and actually. Are they still in? Did they leave Mr. Harris? Okay. This is the lab for 13. We got the main part going. I just letting this late student in. Okay, so I think I have to go like this. There it is. No, come back. Tools, attendance. Awesome sauce. And okay. Oh, I guess he was already in here. Okay, that's fine. Okay. Let me see. Do I need to reboot you? Okay, it looks like it's working okay. Let me hop back. No. Hop back over here. Okay. I'm gonna go with it. And if it slows me down, I know what I need to do. Okay, no real announcements. Oh, and I will be monitoring the chat, so just feel free to use the chat. Feel free to use the chat if you have any questions or inquiries about anything. Let's at least hit our mark for. Let's go ahead and give him credit. Let's at least hit our mark of what we need to do for. This was this guy. What we need to do as far as the lecture, we usually have a good amount of free time. I know this isn't right. Let me get to where we left off. We left off right about here, right? That was the last thing we did on Monday. Okay. So then from this point, that's what? 17. So if there were 18, so about 10, so about the 20. That's not too difficult. Okay. So we're in chapter 2. Remember, exam 2 was available from last week on Wednesday until Saturday, and actually you can work on it past the deadline, but it'll be a 10% late penalty. Midterm grade was based on whatever scores I had in Pearson. That's going to be 90% of your grade, and the other 10% was if I had something or not in Alex. Okay, so Alex is going to count as 10% of our grade. For right now, if you have questions, type it into the chat. Once we're done with the portion of the lecture that we need to do today, we can use the rest of the time to kind of answer homework questions. I'll just use it as a study session, right? So, hopefully you guys are on top of your homework. There was a question that was asked last time that was really good. It kind of matched the time. I think it was relevant. It kind of had us bring out relevant topics and issues. So let's continue where we left off with the quadratic function. So this is the slide. This is the next slide from wherever we left off last time. And we're actually sketch the graph of this. All right. So I'm going to add a page. And I'm going to get a copy of this so we can sketch the graph. Now I don't mind if you guys like unmute yourself, but then it's like sometimes I just need to focus, so I will like force the mute all and won't allow you to unmute. But I'm giggling because I was watching the latest episode of South Park, and so it's the pandemic special. Red is trying to save everybody. South Park is doing that classic South Park stuff. And so Mr. Mackey was trying to do like a town hall. He had all the residents of South Park. Should be working. Oh, are you disconnected? What's the deal? Let's go paper. We need this. Come on. Why are you acting up? Okay. It's because I said South Park. Anyway. But yeah, so he had everybody on Zoom, and like they was all losing their mind, and he was like, okay, mute everybody. He was like, that's right. It's like, it was just funny. Like, South Park is hilarious. Anyway, but it's similar to what I experienced on my end, so I totally resonated with what he was experiencing. You can actually see your midterm grades. So let me make this statement about midterm grades. Midterm grades don't really hold any value. All it is just a snapshot of where you are at the halfway mark, based on whatever data I have on file. I think this is before most people took their exam too, right? So the one that matters is the final grade. The midterm grade is just a snapshot. It can change drastically for everybody and anybody that wants it to change or doesn't want it to change, right? So again, it's just a snapshot. It doesn't really hold any weight or value. But what matters is towards the end, you know. And another word to the wise, like we don't, our rhythm is very leisure. So hopefully you're taking advantage of this rhythm. Hopefully you're able to take advantage of this rhythm, because as we get closer to the end of the semester, Pearson more than likely will start to slow down because everybody's going to be on Pearson at the same time, and usually it just locks up. It throws a hissy fit. So the recommendation is just to stay current on as many assignments as possible, so that way when we get to the end of the semester, you have minimal work that you need to do. That's a great position to be in. Okay. But yeah, the midterm grade. So if you open up the portal and go to Bannerweb, you can see your midterm grade there. It's not going to be in Blackboard, it's in Bannerweb. Okay. So in this example, we're asked to sketch the graph of this quadratic in standard form. In standard form, right? In this form, we automatically see where the coordinates of the vertex, right? So the vertex, again, being our h comma k, is like this. So then from here, our vertex is going to be -2 comma 12, right? So the h, we do have to change the sign of the h coordinate, the x coordinate. So the sign flips, and then but the y coordinate, which is our k, stays the same. Okay. So then we can plot the vertex, and we can use the vertex to identify the axis of symmetry. And let's just kind of see it in action. So the parabola opens down. We go left 2 and up 12. Okay, so let's make some graphic. So positive x is going to go this way, like this. Positive y is going to go this way. I keep getting because I keep thinking about South Park. It never really goes the direction I think. I just knew Cartman was going to find some way to keep everyone, remote distance, social distancing and remote learning and stuff, because he always acted like his connection was bad. So they always, well, just do your best, Eric, and he would just turn it off and go do whatever he wanted to do. So he was in like heaven. Copy, paste. So I'm just creating the graph paper for right now. Let's get rid of this, and then let's paste, and let's do like this. We're gonna rotate it, and then here. Let's paste it again. Let's just undo. Yeah. Redo. Okay, that's fine. Let's copy. I'll deal with that student in a moment. Let's paste. We need what? 1, 2, 3. 2, 3 looks good. 1, 2. Okay. Let me finish this graph paper, then I will let the student in. So this is like the origin. Let me see if we're going to 12 on the y-axis. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7. Okay. 2, 4. I'm going to go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay. These are negative values. All right. So we got some graph paper. Let's do like this. All right. Let them in, and let's log it here. So I found a new system that seems like it's working a lot more smoothly, if it's proper. Okay, so this h comma k, this -2, 12 are going to be the coordinates of our vertex, right? So, and let's do like this, paper, switch it to this one. So if we go left 2 and then up to 12 is here. So that's the coordinates of the vertex. So then once we have the coordinates of the vertex, that identifies our axis of symmetry. All right. So this axis of symmetry will tell us, I'm going to go style, kind of like this, and then like this. That looks good. So our axis of symmetry is the axis for the parabola, right? Whenever we get a point on the left, we automatically get a point on the right. So for instance, when x is, what is that, -1? So when x is -1. So what I'm going to do, I'm going to plug this into my calculator to crunch the number. I know we can practice doing it in our head and all, but I want you to just see some of the capabilities of the calculator, of a graphing calculator. Reload and refresh. Come on. Awesome sauce. Okay. So then I'm going to go to my y equals in the upper left-hand corner. I'm going to type in the original, which is this -3 times x plus 2 quantity squared plus 12. Okay. I'm going to quit. And then, so if we look at the clear button, to the left of the clear button, it says VARS. I'm going to click on that. I think it stands for variables. I'm going to go to the right to go to y variables. I'm going to click on number 1 to call function and number 1 to call the function that we just typed in. So just as a quick test, when x is -2, y should be 12. So we've confirmed that one. Now we wanted to know when x was -1, what's our y value. So I'm just going to recall and change that 2 to a -1. So when x is -1, y is 9, right? So that's right here. We have this point. But what this means is if we go one step to the right, we're at 9. Also, if we go one step to the left, we're also at 9. All right? So that's how we use the axis of symmetry for a parabola. Whenever we get a point on one side, we automatically get a point on the other. Let's do when x is 0. I'm curious if we can do -0. It should be 0. Okay. So when x is 0, our y is 0, right? So this parabola is going to pass through the origin. If we go 2 to the right, we're at 0. That means if we go 2 to the left, we're also at 0, right? And I think 1 goes off the chart for us, right? So then we're just going to connect those points with a smooth curve. Something like that. Let's see, that can go there. That can go about there. That actually looks pretty good. Only other thing I want to do, oops, not like that. Okay, let's do that. Just drawing some arrows. Okay, that looks good. All right, so we drew this graph by hand, and then we have a computer generated a little bit further down. Okay. So here's one of us doing it by hand. Let's go to view, single page. And let's go paper. We can do, let's just do it for white right now. Okay. So notice the leading coefficient is negative. The parabola opens downward. The coordinates of the vertex are going to be -2 and 12. Okay. They found the x-intercepts. I think we found the same thing. They got what, like 0 and -4? I think that's what we got. The y-intercept, what they did is they set x to 0 and solve, and I think, what did they get? Oh, 0, right? The origin. So the y-intercept is 0 as well in this case. Oh. And I think we got the same graph. Again, if anything is not clear, feel free in the chat to type your questions. Okay. I think I'm going to go a little bit further. I might try to finish out this section today. So then on Thursday, we can take some time to like do some review on factoring. In addition to, we still have like our regular homework that we do and also Alex. So, hopefully you're making your way through Alex. Alex is going to count as 10% of our grade. Pearson counts as 90% of our grade. Okay. Let's see. Okay, so we did that one. So we're asked to sketch the graph of this one. So now in that last example, our function was given to us in a standard form, the standard form of a quadratic. I think last time for you all, we automatically went to using the vertex formula to find the coordinates of the vertex. So I want to do a demo for this group on completing the square and then how to transform it from the general form to the standard form of a quadratic. We could easily use the vertex formula like we did last time. That'll take us right there. It's quick, but it doesn't hurt to also know how to do completing the square. So let's go ahead and get a copy. Let's go ahead and change the view. Let's go paper. We're gonna need graph paper, and we want the view to be seamless. Let me get a copy of this. Hey Google, play some chill hop music from YouTube on the basement TV. Hey Google, change the volume to 10%. Can't even hear that now. Oh, that's a nice image though. Hey Google, change the volume to 17%. Okay, that's fine. All right. Hopefully it's not copywritten because if it's copywritten, that might take down my video. But it's not a big deal. But I would like to know if that's going to be an issue or not. Okay. So we want to find the coordinates of the vertex. Now again, we can use the vertex formula. I'm going to let you kind of look back to see that, or just kind of do a little bit of digging to find the vertex formula. Hopefully you wrote it down from last time. I want to do a demo on completing the square. Okay. It's completing the square is going to be a little bit more involved, but I just want to do a demo on completing. Is there an E or no? I don't think there is. Completing the square. Hey Siri, spell completing.
Completing. Yeah. C O
okay. Hey Siri.
M P
Hey Siri.
L E T.
Thank you. I got it. Completing the square. Okay. So let's start with the original. We have this. So now this is going to be an example on completing the square on one side of the equation. We're not going to go back and forth. I usually will work both sides simultaneously, but with this one, we're just going to work on one side. So the first goal of completing the square is to get that leading coefficient to be a 1. Right now our leading coefficient is 2. Right? So what we need to do is factor out a 2 from all the terms. So this is going to be equal to, actually, I'm only going to factor out the 2 from the first two terms, from the 2 and the 8, right? So if we factor out 2, we're going to be left with x squared plus 4x. I'm going to leave a little bit of space, and this minus 10 has been untouched, right? So now the completing the square step comes in the following way. How does this look? I think I'd rather try this one. I think that pops a little bit. Okay, completing the square comes in the form of we're basically gonna add 0. Uh-oh. No, go away. Stop that. Can I hit enter? Okay. So we're gonna add 0 in the form of b over 2 squared, and basically we're gonna add it and we're gonna also subtract it back, right? So we're adding 0, but this is the completing the square step. This part in orange here. I was making the curves dance to the music. I'm totally like just trying to wake myself up. Okay. So completing the square, we're going to add 0 in this form. I probably need a little bit more space. Yeah, let me write it for now. So our b in this case is going to be 8. So we're going to say, I just need some space. Let me make some space. So like for instance, u can go here. U can go a little bit more flush. You need to go about there. That's pretty good actually. So b is going to be 8. So we're going to say plus 8 over 2 squared and minus 8 over 2 squared. So again, adding 0 doesn't change the equation. It doesn't change the function. It just puts it in a form. This technique allows us to put it in a form where we can factor it, right? So if we keep going, the 2 comes down, x squared persists, this persists. Now 8 divided by 2 is 4. 4 squared is going to be 16. So we're saying plus 16 minus 16. Okay? Minus 10. Okay? So now if we were to distribute this 2, I want to leave the first 3 separate, and that minus 16, I want to get it out of the parentheses, so we need to multiply it by 2. So then we're going to have the following. 2 times x squared plus 4x. Again, this plus 16 persists. Let me see. 2 times negative 16 is going to be negative 32. So I'm going to write it like this. Minus 32, and then the minus 10. Okay? So now if we look at the first 3 terms, they factor. We can factor those first 3. We're looking for 2 numbers that multiply to give us 16 and add to give us 4. Let me see if that works. 4 times 4, 2. No, wait a minute. Maybe not. B over 2. 8 divided by 2 is 4 squared is 16. Is it 4? It's not 4. B over 2. What am I missing? Oh, I see. I see what I did wrong. I used the wrong B. That's where it is. I was like, man, why are these numbers so big? I'm just going to erase the errors, right? It's not supposed to be 8 divided by 2. Our B was actually 4. I was using the line above. So I'm going to do this. Get rid of the thing I know is wrong. This is wrong. Okay. So it's not supposed to be 8. It was supposed to be 4. That was supposed to be, our B was actually 4 after we factored out that 2, right? I thought those numbers were kind of large, right? So then 4 divided by 2 is 2, but 2 squared. So we're saying plus 4 and minus 4. Those are the 2 numbers. So then, again, the first plus 4 persists. And then 4 times 2 is going to be negative 8. Okay, now I think we're ready to rock and roll. So now the first 2 numbers that multiply to give us 4 and add to give us 4 is what? 2, right? 2 and 2. So this becomes 2 times x plus 2, because 2 squared is 2. 2 times 2 is 4, and 2 plus 2 is 4. X plus 2 squared minus, what is it, 18. So that was a demo on using completing the square to transform from the general form of the quadratic to the standard form of the quadratic. So the first line was the general form. The final line is a standard form. Okay, that takes effort and practice. Completing the square is not, it's not always simple, but whenever we have a quadratic, we can if the quadratic is solvable, we can always use completing the square to solve it. But it takes a little bit of effort. So I have a chapter that's devoted to factoring techniques. I'm going to talk about this on Thursday. My goal today is to try to finish out with this section so that we can have a little bit of time on Thursday, and then we can take Friday to kind of go through some of the homework for this section, and we'll mix it up and things of that nature. Okay, we're pretty good on time. So now in this form, we can identify the vertex. All right. So the vertex being our h comma, that's not an h, being our h comma k. H in this case is going to be, you always have to kind of change the sign. It's going to be negative 2, and the k is going to be negative 18. Now, we could have used the vertex formula and jumped straight to these results. The vertex formula being negative b over 2a. That'll give us the x coordinate of the vertex. Then we use the x to find the corresponding y. Okay? So now if we're going to graph, okay, so now let's go ahead and make some graph paper. So we went left 2 and down 8, and the parabola opens upward. Okay. So let me make some graph paper. Opens up, left 2 and down 8. So we're going to kind of work like this. Okay. Then we need to kind of go this way. Totally not straight. That looks good though. Okay. Let's move you this way a little bit. Okay, that looks okay. Okay, so let's make our tick marks. Let's go 1, 2, 3, 4, 5, 6, 7. Let me just copy and paste. That seems like it works fairly well. Let's copy, paste. That's good enough. Let's paste and rotate. Okay, let's go this way first. Copy. how many we need? One. I mean, I could do that. But let's do 1, 2, 3, 4, 5. 3, 4, 5. Okay. 1, 2, 3. Okay, that looks good. All right, and then let's label these. So this is the origin. 1, 2, 3, 4, 5, 6, 7. These are negative values. We're going -2 and -18, so let's go by twos. 2, 4. Negative. Okay. Let's undo that last one. All right, so let's plot this vertex. We have a vertex of -2, -18. Stop that. Thank you. -2. Oh, let's do it like this. Paper. So -2 is here. -18 is here. All right, this is the vertex. So this also identifies our axis of symmetry. Nope, that's not what I want. Okay, so then again, we can still use the same point. Once we have the vertex, again, then we automatically get the axis of symmetry, and then basically whenever we get a point on one side, we automatically get a point on the other. So let's do when x is -1, right? So I'm gonna use my calculator again. I mean, we can do this one by hand. I mean, mentally, right? So that's gonna be a +1, so that's gonna be 2. 2 minus 8 is a -6. So it's gonna be -16. Okay, that could be the case. So -1. So 1 to the right, we're at -16. If we go 1 to the left, we're also at -16. Okay. I'm still going to just use my calculator just as good measure. So in my calculator, what I'm going to do is go to my y equals and change that out. 2x squared plus 8x minus 10. I'm going to quit. I'm going to go to my variables, y variables, calling on the function. Let's confirm when x is -2, y should be -18. When x is -1, we got -16. Okay, so that means one to the left and one to the right, they're going to have the same y value. Let's do when x is 0. Let's do when x is 0. So when x is 0, y is -10. So if we go 2 to the right, the y value, 2 to the right of the axis of symmetry, y value is going to be -10. If we go 2 to the left, 1, 2 is here, also -10. Let's just go ahead and do when x is 1. 0. So when x is 1, y is 0. So if we go 3 to the right, we're at 0. If we go 3 to the left, 1, 2, 3, we're here. I think 2 goes off the chart. Let me just try 2 really quickly. 14, right? That's too high. So now we just connect the dots with a smooth curve. I'm going to do something like this. Okay. Then let me see if that's there. I want that about there. Yeah, that looks good. And then this one, I'm going to make it about here. Okay. And then you, nope. So let's see, let's move you there. Move you there. Oh, it's close. It's actually good. That works for me. Okay. And then I'm just going to include some arrows so you know to continue the pattern indefinitely in these directions. Okay, that looks good. All right. And to me, like, graphing is the fun part. Like, because it's like you're drawing a picture, right? And so this picture is like it's a graphical representation of all the solutions of this equation of this function. So given any x value, this is just a graph of all the solutions, all the x and y corresponding order pairs that make the original equation true. All right. So we drew this one by hand. Okay, you saw all the components. We started with the vertex. We identified our axis of symmetry. Then we use the axis of symmetry to create the graph. Okay, let's go to view, single page. Let me see. What's the time looking like? 4:32. Yeah, let's keep going. All right, if we can, I think we can finish this today, and then we'll take the second half to just kind of work problem sets and get some practice in. Try to fill in some stuff. Okay, so now in the notes, what they did, they used the vertex formula, right? So I think we introduced that last time. So hopefully you can pull it. It's actually showing on the screen, but I'll let you kind of discover that. If we get another graph, then I'll use the vertex formula if needed, if I can. They found the x-intercepts, the y-intercepts. Because we were working with a parabola, I just used the axis of symmetry. Whenever I got a point on the right, I automatically got a point on the left, and we still got all the same points, right? I think we had that same graph. So it says the graph of this is shown. Find the domain and range of f, and then solve this inequality. When is this graph positive or above the x-axis? So honestly, all the answers are actually showing for this one, right? It says the domain. So the domain of a graph, I want to color that pops. Let's do something like this. Style. We need some thickness. Okay. So the domain is going to be the very left to the very right. So no matter how far left we go, we can always, no matter what x value we choose going to the left, we can find the corresponding y. It looks like it doesn't connect here, but again, if you continue the pattern going in this direction, then we'll find the corresponding y for any x to the left, right? So the domain, the very left to the very right, the far left is negative infinity, the far right is positive infinity. Then so if the domain is the very left to the very right, then the range is going to be the very bottom to the very top. How far down does this graph go? So no matter how far down we go, we can find corresponding x to whatever, no matter what y value we choose going down. But then, so the very bottom looks like it's going to be negative infinity. But then the very top, the highest y value, it has a turning point right here. Highest y value is 3. So the range would be from negative infinity up to 3. Okay. Again, be sure to make use of the chat if anything is not clear, if we need to go back or revisit any notion or idea. Okay. And then honestly, I mean, we can solve it algebraically, and I probably will go ahead and do it algebraically. But this is basically saying, part B is saying, when is this quadratic positive or when is it above the x-axis? When are your y values above the x-axis? So if we look at the image, it's above the x-axis when x is between, oh, but we need those intercepts, right? Whatever those intercepts are, here they are. When x is between 4 plus or minus root 6 over 2. Okay, let's do this algebraically. But we can see that, oh, the graph is above between the x values, or the graph is positive, which is above the x-axis, between the x-intercepts. But let's solve this algebraically, right? So I think we've identified the domain and range. Let's solve this inequality algebraically. So let me do the following. Let me add a page. I'm totally sleepy. I need to change this. Let's go to view, seamless, and let's go to paper. Let's get some graph paper going. Okay. So then let's get a copy of this question. We really need part B. We don't need that. I just want this really. I realize why I'm so sleepy now. Part of the reason I'm so sleepy, I finally like got out of the house and got when I did some exercise. I went running, and so I noticed like zapping on my energy. So I just want to like I've already kind of eaten, so I just want to like go to sleep so bad. But we need to do what we need to do. We have to have integrity. If you don't have integrity, you ain't got nothing. Obviously, that's the PG version, and that's just a pulling from South Park and actual life things. South Park is hilarious. It's actually one of my favorite shows. It's just so silly, but they be saying relevant things actually a lot of times. Sometimes they just do things just to be stupid. But like one of my favorite scenes was when we first had the economic crisis. Like I think it was before. I think it was during Bush. I know it was before Obama. But like everybody's worried about the economy, and I know Black American Expresses were big at that time. So Kyle was approved. You know all this stuff about Jewish and buddy. I was like, oh my god, this is so. but Kyle was approved for the Black American Express, and so he decided to pay everyone's debt, like he was a martyr, like he was a savior, a Jewish savior. He paid everyone's debt, and his mom was freaking out. He was like, Kyle, you'll be in debt forever. And she was like, "Mom, I got to stimulate the economy. I gotta take this and save everybody." And so when he paid everybody's debt, he like splayed out like, "Ah, I can't do it anymore." And they're like, it's like he saved us. He's our savior. You know, it was hilarious. But it's like, what would happen? I think that's a very interesting idea, creative and interesting. What if somebody took a Black American Express? The Black American Express has no limit on it. So what if you just put everybody's debt, like just make an account and like that one account just ate it all, and then everybody's debt would pay, and they can actually go to stimulate the economy again. I just thought it was an interesting idea, but because those cards have no limits on them. So anyway, enough of the detour. So let's solve this inequality algebraically, right? Because I think that's a useful skill or a useful thing to look at, right? So let's start here by getting a copy of the original. 2x squared. Every time I think about it, it makes me smile though. Like this, right? So the suggestion here, basically we solve it like an equation. We want to see, can we factor this, right? Let me see, can we factor this? Two numbers that multiply to give us 10 and add to give us 8. It's only 5 and 2, so we can't factor it that way. We could do completing the square. We can use the quadratic formula, right? So only thing I can see here is the quadratic formula. So let's just, and we can also do completing the square, but we've already done one completing the square, so I'm going to go ahead and do quadratic formula. This was going to be a little bit more involved if we try to do completing the square. I don't think we would have, we're not going to have fractions. Well, anyway, to me, what's more simple to solve this one, to find those x-intercepts is gonna be the quadratic formula, right? So as a quick refresher, the quadratic formula, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. I know it might not be, it's a little bit non-PC, but that's the way one of my students remembered it, and it just clicked in my mind like a mini movie. So that's how I remember the quadratic formula. So other students in the past would try to use songs, but I would always, every time I tried to remember, I would forget the tune. I would change the tunes to different songs, and I couldn't remember the rhythm. But the movie technique for me worked, and you don't have to do that. Okay, let's identify. Like, you just need to find something that works for you. Let's go ahead and identify our A, B, and C. So it looks like our A, we got is -2, our B is 8, and our C is -5. Okay? So then if we plug these in, our x is going to be -8 plus or minus the square root of 8 times 8 is 64 minus 4. Our A is -2 and our C is -5. Okay? All over 2 times A, so our A is -2. I really like the image, but this music sounds weird to me. It's not really chill. Hey Google, next. But I like the image. Alright, we're gonna try this one. It's kind of okay. So let's keep going. Okay. We're gonna get -8 plus or minus, let me see, 64 minus something. 4 times 2 is what? 8 times 5 is 40. So fortunately, it's still positive over -4. Okay. We keep going. What is that? 24, square root of 24 over negative 4. 24 is what? 4 times 6. So square root of 4 ends up being 2. So that's going to be negative 8 plus or minus 2 times the square root of 6 over negative 4. And then one more. Everything is divisible by 2. Let's divide everything by negative 2. If we divide all the terms by negative 2, that becomes 4 plus or minus 2 times the square root of 6 over 2, right? Actually, we could do 4. Nope, nope, nope. Right here. This is gone. That's better. I think that's better. Yeah, that looks proper. Okay. I didn't divide the second one by 2. Okay. It feels like every time I turn around, Mercury's in retrograde. Okay. So these are going to be the coordinates of the x-intercepts, right? So then, okay. So what we have to do to finish out to solve this inequality, right here, let's add a page. So so now we have the x-intercepts. So basically what's happening, square root of 1, square root of 4, square root of 9. So that's like 2 point something. Okay. So these x-intercepts, what it's doing, if we plot these x-intercepts, hang on, let's do it like this. So positive x is going to the right. This is so positive x is going in this direction. So like for instance, if we plot these x-intercepts, one is going to be there, one is going to be here, right? This might be our 4 minus the square root of 6 over 2, and this might be our 4 plus the square root of 6 over 2, right? Whatever those numbers are, some decimals. So then what does that, so at these x values, our y value is 0, right? So, and let me see, if we look at the original, is negative, so the parabola opens downward. So we're kind of anticipating an image that looks something like this. Here, let me kind of do something a little bit different here. So we're kind of anticipating a parabola behaving something like this. Okay, that's fine for now. And let me make a few adjustments down here. And style, we can make it about that thickness and about like that, put it like this. That's fine. So, but anyway, we're anticipating a parabola to behave something like this. Again, we said it opens downward and it has these x-intercepts. So this breaks the number line up into 3 segments. We got the far left, the middle, and the right. So what we're going to do is choose a number to the left of this. That's like 2 point something. That's going to be 2. So this number should be positive. So I'm just going to choose like -1, right? If I plug -1 into the original, let me go like this. If I plug -1 into the original, I just want something to the left. I want something over here, right? I'm pretty sure -1 is over there. If we plug -1 into the original, then we need to see what kind of output we get, right? So let's look at we're going to pull up the calculator. And let me just check some things, right? So, for instance, I'm going to check that 4 minus the square root of 6 over 2. 4 minus this, it should be like 1 point something or 2 point something. 4 minus the square root of 6, the top divided by 2. So slightly less than 1, but still positive. So then -1 is to the left. Nope, I need you to go away. So then looking at the original, when x is -1, so I'm going to go to the top to my y equals, and I want to type in that original. We got this -2x squared plus 8x minus 5, right? I'm going to quit, clear. I'm going to go to variables, y variables, number 1 and number 1, right? I'm just calling on that function that we just typed in. And now we want to see when x is -1, what's our y value. So what it's saying is that basically all the y values to the left of this key number should be negative, right? So everything to the left over there, everything on the left is going to be negative or below the x-axis. So then we want to test something between these two. So it looks like no, not 0. Maybe let's do when x is 1, because x equal to 1 should be between those two, and it's positive. So what it's saying is that everything between these two key numbers should be positive or above the x-axis. And then let me see, what's that? 4 plus the square root of 6. I'm just gonna recall this one and change that minus to a plus. So that's like 3 point something. So something to the right of that, I'm going to choose when x is 4. So when x is 4, I'm anticipating it to be negative. So everything to the right of that key number should be below the x-axis, right? So then to answer the original question, when is this above the x-axis? So now it's clear. We get a positive result when we're between our x-intercepts. That's a lot. This always gives students a hard time. They always feel intimidated, overwhelmed. It just takes practice. I'm just showing you, and like fortunately, hopefully you can take this recording that's being streamed on YouTube and you can go back, watch it, pause it, rewind it, flip it, chop it, screw it, do whatever you need to do so that it can kind of sink in. But it takes practice. All I did, I found the x-intercepts, and it breaks the number line up into segments. All right, you got this far left segment over here. Come on, far left. So anything to the left of that, is all gonna, it typically behaves the same way. Let's go like this. Maybe that'll help some, maybe. And then hopefully that's not too many lines. Let's copy, paste, and then this other x-intercept. So it breaks it up into, the intercepts break the number line up into like different segments, right? In this case, the two intercepts broke the number line up into 3 segments. Everything to the left of everything basically going in this direction is all below the x-axis. Everything between these two is all above the x-axis, and everything to the right is all below again, right? So then now we're poised or primed to answer the question, when is the parabola positive, or when is it above the x-axis? Basically between the x-intercepts. Let me see. It says strictly greater than 0. So then the solution is going to be basically, it's between 4 minus the square root of 6 over 2 and 4 plus the square root of 6 over 2. And we're going to use parentheses here because we don't want it to be equal to 0 because of this guy right here. There's no bar, so we use parentheses. So we're saying between these intercepts is where the graph is going to be positive. And we can check. So if we're saying between this, if we choose any number between these two, we should get a positive result. If we choose any number outside this set, we should get a negative result. For the sake of time, I am not going to check it. I'm going to use my notes. Let's see what we're looking like. What did we say? 3. They start at what, 5:15? I think you guys go into 5:05. Let's go paper. Let's go to view. Let's go here to paper. Okay. Let me see. We might have one more after this. So let's see, how do we do? We said between the x-intercepts. So the domain was all reals. The range was -infinity to 3. And then the graph is above the x-axis on the interval from 4 minus root 6 over 2 and 4 plus root 6 over 2. Okay? So again, because this is a recording, you're going to have to go back, watch it, pause, get help. Keep in mind that you've already paid for a tutor. You just need to call on them. If you're a student, most schools, especially at the collegiate level, tutor payment is included in your tuition, right? So Morehouse, I'm pretty sure, does the same thing. Just call the math department, and they'll give you instructions on how to connect with the tutors. Okay. See, Ali, it looks like it's okay. Okay. Let me see what else we got. Find the dimensions of a rectangular garden of maximum area if the perimeter of the garden is this feet. What is the maximum area of each rectangle? Okay, this sounds like fun. So what I'm going to do, I'm going to start by drawing a picture. I'm going to create some space for myself. Seamless. it says find the dimensions, and let's do like this. Paper. I usually like to work on graph paper. Find the dimensions of a rectangular garden. So the basic shape that we're working with, since this is a garden, basic shape is a rectangle. So first I'm going to start by drawing a rectangle. Like this, right? So here's our rectangular garden. It says of maximum area, so we want to maximize the area. It says the perimeter of the garden is 80 feet. So it says that the perimeter is 80 feet. Okay. Let x be the width and y be the length. Okay. So we're going to say width, right? We're going to let this be x and we're going to let this be y. All right. It might be different than what the book has, but I'm going to go with it. So now if we're going to do the perimeter, think for a moment, ask yourself, what's the formula for perimeter? Right? And hopefully you're aware that there's no set formula for perimeter. Perimeter is not a set formula, it's more of a concept. Perimeter is just the distance around the outside, right? So depending on the shape, that's going to change the quote unquote formula. But in this case, since it's a rectangle, perimeter can be expressed as basically what? 2x plus 2y equals 80, right? We're going to let this be the length. Let me see. Oh, and that be the length. Okay, I'm going to switch them around. So I'm going to let this be the width. I'm going to move this to the bottom. It doesn't really matter. And I'm going to let this be, I think this is my next class. Is that this class? I think he might be in this class. I am not feeling this music though. Let me see if I can get to the bottom of this. No, he's not in this class. I'm going to let him stay there. He's in my next class. Okay. And let me just switch this around a little bit. So I want you there. I want you like here. You can go here. And let's copy and go ahead and paste you here. And this is the length. And this is the length. Okay. All right. So we want to maximize the area, right? So then area of a rectangle is basically the length times the width, so that's going to be x times y, right? So we have two unknowns, we have two equations. We really have three, but let's kind of keep going because basically what I'm going to do is express the area in terms of one of the variables. So what I'm going to do, I'm going to solve for y in the first equation, right? So let me start with the first equation. If we have this 2x plus 2y equals 80, if we solve for y, subtract the 2x, so we're going to have 2y equals 80 minus 2x. Divide both sides by 2, y equals 40 minus x, right? So then what I want to do is take this and plug it into the second equation. So then the area can be expressed as x times y, but y is 40 minus x, right? So now we have area in terms of x, right? So let's keep going. So our area in terms of x is going to be, if we distribute this guy, let's do it this way. It's going to be negative x squared plus 40x. Okay, so this should look familiar, right? The theme of this whole section has been quadratics. Notice that the highest exponent is 2, so this is a quadratic. So now we have an expression for the area is parabolic in nature, or is behaving like a parabola or a quadratic, which is going to be a U-shaped graph. The leading coefficient is negative, so the U-shaped graph is going to open downward, right? We can see that, you should be able to quickly see that one of the intercepts is going to be the origin. But we have a U-shaped graph that's opening downward. So if we want to maximize the area, where is the maximum going to occur? If we have a U-shaped graph that opens downward, the maximum is going to occur at the vertex, right? So we have a formula to go straight to the vertex. The vertex, the x-coordinate of a vertex, which is h, is going to be negative b over 2a. Okay? So then our b in this case, we're going to say negative, our b is 40 over 2 times our a is negative 1. So the x-coordinate of the vertex is going to be 20. Let me give myself some more space. So I'm not trying to cram it all in. Add a page. Okay. We're almost done. Okay. So the x-coordinate of our vertex is going to be 20. Let's go and find the y-coordinate of our vertex. So again, the y-coordinate of the vertex, which is our k, is going to be f of h. In this case, it's going to be f of 20. So we're going to plug 20 into our area formula. This is a lot. You just have to do the best you can, okay? You have support. Like, just take advantage of this remote thing. You can actually, I mean, but do your best to be genuine. Just get it done. And then just kind of be prepared to, you know, defend yourself or whatever at any moment. It's like what I always see is like with this whole remote learning, even though everything is remote and things are kind of lax, sooner or later you're gonna have to take a test in a testing environment to show what you've learned. So you know, I get whatever you decide to do. I totally get it, but at some point you just be aware you're gonna have to show what you've learned, and you know if you've been like slacking off or not really doing it, it's gonna show, and it's gonna kind of get in your way. But for right now, you know, this is what we kind of have to do. So I want to plug 20 in. Okay, so we want to do a of 20. It's going to be negative 20 squared. And let's do it, well, you don't really need to do that. Plus 40 times 20. 400, negative 400. Plus 800 is 400, right? So the coordinates of the vertex are going to be 20, comma 400. So when x is 20, the area is going to be 400, I think it's square feet. So let's go back and answer the question. It says find the dimensions. So if x is 20, okay, I guess we can use the 2x plus 2y equals 80. So then we'll use this 2x plus 2y equals 80. So if x is 20, now let's find the y value. Right? So what is that? 40. If we subtract 40 on both sides, that's going to be 40. 40 divided by 2, y equals 20 as well. Okay? So it's pretty much a square. So it looks like our x is going to be, what, 20 feet? And our y is going to be 20 feet. Okay? So with a perimeter of 80 feet and maximizing the area, these should be the dimensions. Okay? 20 feet by 20 feet, so it should be a square. Okay, let's see how do we do. Okay, I'm about to let you guys go. All right, and let's do view, single page. And again, I'll make a copy of all the stuff you see me writing. I will make a copy available. Let me see the time. Yeah, let me wrap this up. 20, okay. So it says the perimeter is 2x plus 2y, which is 80. Okay, so then they solve for y like we did, right? We solved for y. Then we had an expression for area. Area of a rectangle is length times width. The x persisted. The y we just found was 40 minus x. So then you see that there. So 20 feet by 20 feet, and basically it's a square. Okay. Let me go ahead and load a copy of this. Let me share. I want to send it to Box. Not that class. I want to send it to this one. This. For this class. Notes. I think these are my next students. So, yeah, these are my next set of students. Okay. So I'm loading a copy of any notes. That's okay. We're about to. It's okay. I'm not going to change attendance, but I'm loading a copy of the notes that you saw me. Let me see. Is that him in the waiting room? User. Yeah, it's fine because I think a lot of these are the next set of students. So yeah, I went on a loaded copy of any notes that you saw me working on into our shared Box folder. You can pull the notes there. The recording for this is on YouTube, and it doesn't hurt to watch my sessions with my other students as well. Just because I kind of work it a little bit differently for each group, so y'all can have, as a collective, y'all will be a little bit more well-rounded. So some techniques I use with you all, I don't do for others, and vice versa. So you definitely want to just check out the lectures from other groups, okay? If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. We'll be back on Thursday at 3:50. Okay, guys, take care. See ya.